Okay, in today's lesson, we are going to be learning what is called the base 5 concept. In the base 5 concept, we can use this to add, we can use the base 5 to learn a base 10 concept, we can have a base 16 concept, you can have any base that you want, and it's how you count. So for instance, on the base 5, we're counting by 5s, and in base 10, you would be counting by 10s. So today we're going to learn the base 5s. We do need to learn that one little box here, it's what called a single, is just 1. When you have 5 of these little 1 singles, we move into what's called 1 5, or other words, a flat. So you have 5 singles. When you have 5 flats, 1, 2, 3, 4, and 5, they make up a full 25. So it's a barely easy concept to think of. You have 1 singles, 5 singles make up 1 flat, 5 flats make up a 25. So it's going to be the same concept when we put our numbers into our chip models here. The chip models are used easier for us to count on, so we can break these numbers up into the ones place, the fives place, the 25 place, the 125 place, and so on. So you're just going to put them in the place that they go, and then you're going to group them based on our logic here, or our base 5 concepts. So the singles, the flats, and the 25s. So our first example is 113 and 221. So both of these are in parentheses to the 5th base. So we're going to take, of course, our ones place, our 5th place, and our 25th place, and we are going to put these into our chip model. So of course we have a 3, so you're going to draw 3 singles. We have 1 single in the 5th place. We have 1 single in the 25th place. And that's how you would draw 113 to the base 5. So we have 21 to the base 5. So we have 1 single in the 1 place and 2 singles in the 5th place. Now I want to look at this and see, is there anywhere on here where I have more than 5? Because if we have more than 5, then we're not using the base 5, because our digits are only 1, 2, 3, and 4. And if we have a 5th digit, the 5th digit will bring us up into the higher, so we would go into a flat. So 5 singles makes a flat. So I want to look on anywhere on here, and do I have more than 5? In the ones place, I only have 1, 2, 3, and 4. So I don't have any 5. I don't need to group over into the next denominator. I only have 3 in the 5th place, so I don't need to group over. I only have 1 in the 25th place, so I don't need to group over. So you're going to count your ones place, 1, 2, 3, and 4, and you're going to drop that down into the ones place. I have 1, 2, and 3 in the 5th place, so I'm going to drop that down in the 5th place. I only have 125, so I'm going to drop that down into there. Of course, 134 to the 5th place. Our second one is 232 and 20. So I want to group my first one. I have 2 singles in the 1st place, 3 singles in the 5th, and 2 singles in the 25th. I also have 20, and I have 0 in the 1st, so I'm not going to write any singles down, and I have 2 singles in the 5th place. Okay, so of course in the 1st place I don't have any that match up to I only have 2 singles, so I don't have enough to make a flat. So of course my 2, that's all I have, is going to come down into my 1st place. Here in the 5th place, however, I have 1, 2, 3, 4, and 5. So looking back to our rules, 5 singles equals 1 flat, and I have to go up into the next denominator. So I have 5 groups here. This gives me 1 up into the next denominator and leaves me 0 singles. So if I have 0 singles in the fifth, then I have 0 singles in the fifth place. Now I need to look over here, and I had 2 before, and I added 1, so now I have 3 singles. So I'm going to bring my 3 over. And of course this is to the fifth place. That is base 5 concept. It's the concept of knowing that your digits 1, 2, 3, and 4, knowing that if you get that fifth one, that you need to go up higher. So 5 singles equals 1 flat, and if you have 5 flats make in the fives 25. Now what we're going to do is I'm going to give you some problems that were on the homework, and I want you to use your chip model, write in how you would do that with your chip model, and then solve the 2 problems that we have on the bottom. Okay, so our homework problems for our chip model, one was 232 to the base 5 plus 20 to the base 5. Another one was 131 to the base 5 plus 13 to the base 5. Okay, so on these 2 here, I'm going to use this chip model here to solve this. On this model here on your homework, I gave you some singles that were listed, and I needed you to use the singles to figure out the problem that was made. So on the first one here, we have 232 to the fifth base. So I'm going to write that out. Of course, we have 2 singles in the first. We have 3 singles in the fifth. And we have 2 singles in the 25th. Also, we have 20 to the fifth base. We have 0, and we have 2. We have 2 singles in the first. So, of course, I don't need to group those over because it doesn't go higher than 4. We don't have the fifth base to move up into the next column. Here I have 5. So these make one group, which is a flat, so I can move it over. So now I have 3, 0, and 2. And that would be our answer for that. The next one I have 1 single, 3 singles, and 1 single, followed by 3 singles and 1 single. So I only have 1, 2, 3, and 4. That's not enough to move to the next one. 1, 2, 3, and 4, not enough to move to the next one. So I can't group these any higher than what they already are. So we're going to drop down 4 singles in the first, 4 singles in the fifth, and 1 single in the 25th. 144 to the base of 5. Over here on our chip model, I need you to be able to move what we have in our 1st, 5th, and 25th over into what would be the problem. So if you look at here, I have 2 singles, 2 singles, and 1 single. So I have 2 singles in the first place, 2 singles in the 5th place, 1 single in the 25th place to the 5th, plus 1 single and 2 singles. So this would actually be my problem, going reverse into the chip method, into the chip model, into what our problem would be. So I have 122 to the base of 5 plus 21 to the base of 5. That is the basic concept of the base 5. You can use this base 5 to go into addition or subtraction, but you have to remember the concept of it. 1 single is 1, 5 singles is a flat, and then of course 5 flats, you would have the 25th. So if you remember that basic concept, when grouping over like we did here, when we have 5, we go to the next higher denominator, which would be the 25 in this case. If you had another one here, and we had 5 in the ones, that is a group. We have 5 singles, which can make a flat now. We need to move that over here into the 5th place, or the higher denominator. So this would give us an extra one here and X out those. So now we have 0 in the ones place. Now we have 3, 4, and 5. Same thing. We have 5 singles that make up a flat. We need to move to the higher denominator. And now we don't have any left. So this would actually now be 200 to the base of 5. That's the easiest way to think about the base 5 concept. If you can get the base 5 concept down, you can count base 5s, base 10s, whatever your denominator is or whatever your base is, you can pretty much count any high. So you just have to remember, for the base of 5, our digits are 0, 1, 2, 3, and 4. If you get this concept down, the base 5 addition and the base 5 subtraction, you should blow through it with your chip models. If you need to re-go back through this again, we can. We can go back and figure out the base 5s to the base 10, but that would be a different lesson, and we'll get to that another day. And we can count as high as any base that we need. Going back to use our chip models and our concepts. So if you have any questions, please let me know. Otherwise, your homework is prepared for you, and you can come back to this. Thank you.